realize I don't know what time it is when you're watching this. So hello, students, and welcome to the last chapter of the book. I know you guys are sad, but all good things must come to an end. Well, you know, that's not really true when you think about eternal things, because the good things are going to be eternal in heaven. So maybe I need to remove that phrase from my vocabulary. Anyway, chemical equilibrium is the topic I want to talk to you about today. This is chapter 16 of the book, our last chapter. And if you'll remember the chapter before, in chapter 15, we considered this reaction. Remember the video with the Oreos, and Joshie and I represented, I was CO, I think, and Joshie was NO2. And we were talking about effective collisions, right? And as this reaction moved forward. Well, as it turns out, as this reaction begins to happen and more of these products are produced, as you have more and more effective collisions here producing the products over here, something interesting happens. Now I want you to sit down. I'm going to give you, everybody sit down. Are you sitting right now? This is one of those moments where, you know, you like, really, you're telling me this at the very end of the year, and I've been thinking all year long that this is the way it works? Watch this. Wow. An arrow in the other direction. That's right. As these reactants have effective collisions and react with one another and begin to produce products, as the number of products increase, eventually you start having effective collisions over here, and the products react with one another and begin to make reactants. And so that's the idea behind chemical equilibrium. It has to do with this forward reaction right here. And then as the forward reaction begins to happen, then eventually the reverse reaction will begin to take place as well, okay? And actually, usually on paper, I kind of write these arrows like this, just because it's a little easier to write on paper. All right, so this is what we refer to as an equilibrium reaction. You have forward reaction to start with, and then eventually you begin to have reverse reaction. And at some point, it's going to reach what we call chemical equilibrium. So let me draw a graph. And you can look at this in your book if you want to. It's on page 484. But a graph that basically looks like this describes this process. So over here on this timeline, we have the reaction rate. Okay? And you have something that kind of looks like this. And then up here, you've got something that comes down here like that. And up top, we have, let's see, over here, this is time. So as time goes on, right? Up top here, you have the forward reaction. That's how the reaction starts. All right? But as the forward reaction begins to happen, as time goes on, you begin to have this reverse reaction down here. And eventually, you have what we refer to as chemical equilibrium. Right? So eventually you reach this state of chemical equilibrium. And we've got a definition in the book, so we can look at that, and we'll define that in just a second for you. But hopefully this makes sense, right? At the beginning of time here, the time for our reaction, we just have the forward reaction, and that reaction rate's really high, right? Those substances are introduced to one another. In the case of our last equation, the CO and then the NO2 begin to react with one another, and they begin to form the products. And so as time goes on and more products are produced, you begin to have the products reacting with one another in the reverse reaction, and eventually reach this state where the reaction rate of both the reactants and the reaction rate of the products reacting with one another, those rates begin to equal one another, and that's what we refer to as chemical equilibrium. So let's write down that definition. So what is chemical equilibrium? It is, make sure you know this, it is the state that occurs in a chemical reaction when the rate of the forward reaction equals the rate of the reverse reaction. All right, so that's our definition there. And there's actually a lab that you can perform on page, it's also on page 484. Experiment 16.1, really simple with a styrofoam cup, uses water flowing in and out of that cup that has a hole in the side of it to give you a physical representation of what this chemical equilibrium process is like. So that would be a great experiment for you to do at home. But while we're talking about labs, I want to introduce you to my favorite chemistry lab. Are you ready for this? I'm gonna have to take the camera off for just a minute here. Ellie. Hey girl, there she is. There's my favorite chemistry lab. Ellie is my lab partner sometimes when I'm teaching. Sometimes she's in here. I'm actually in her room. There's her kennel there. But there we go. Now you've met my favorite chemistry lab. All right, girl. Okay, so anyway, that's all that we have for this particular lecture. Just one more thing. I don't even know if I'm in the frame here. Hopefully I am. But one more thing to note, that as time goes on, right, as that forward reaction takes place, at first, the concentration of the reactants is really high, right? And then begins to produce more and more products, and so the concentration of the products goes up. And eventually you reach that state of chemical equilibrium. And at that point, since the reaction rates match one another, even though reactions are still taking place, the concentration of both the products and the reactants don't really vary. So it's as if the reaction has stopped at that point. Okay, so that's kind of the way to think about the chemical equilibrium process. All right, I'll see you in the next lecture.